Hi, and welcome to another Basics of Rigging. This time we're going to be talking about zeroing out objects. Now it has there's many terms to say the same thing. Some people call it the initial transform, or the skin pose, or the bind pose. But we're talking about zeroing out because it's more focused on animation, whereas the other ones are more, I guess, modeler friendly to tech art friendly. It's like but the main concept is the same across all of them. If you're looking at it from the point of view of an animator, what you're doing is you're zeroing out a value of something to of an object of any part of the rig, so that the values where you start animating from start at zero. And that's valuable to us because if you reset everything to zero, then you return to your bind pose or whatever you want to call it, to your skin pose. And that's great for animation, but it also has there are other implications of what that can do for us. And there's I won't go into it too much at the beginning, but it's going to allow us to be able to protect us from Euler a little bit as well. And let's dive into it. Let's there's it seems like it's a lot of good things. So in fact, actually, if you don't have this, you're going to have a tough time, because if you don't, your values don't start at zero. Good luck figuring out how to get those original values back, because if you didn't set a key or somehow preserve the initial position in some way, you're not getting it back. So okay, so this is super important. So let's take it step by step. First thing we need to do is if you go to the webpage for the rigonomicon.com, where you probably went to see this video, you're going to see a section that talks about values, which is the one of the golden rules that we have, which is a gold standard for every software. It's not just Maya or whatever else you're using. Every software uses this on some level or another. The translation, rotation, and scale values of any object are always dependent on its parent. If a child is exactly in the same place as its parent, its values are always zero. And you gotta think about that for a second. Just let it think about it. If a child is exactly in the same place as its parent, its values are always zero. Another way to look at this is that your object's coordinates describe how different it is from its parent. All right, so if I have 0, 0, 0 across, it should be exactly in the same place. If, let's say, I have a translation of x of 10, it means the difference between the two is that one's moved along the x-axis by 10 units, and the other one is at the root of that that movement. Okay. So let's see how we can apply this. So the first thing I'm going to do is I'm going to create a cube. Okay, and we're going to just make a few adjustments to the cube because we want to make sure we understand its orientation in space. I would just want to get this so that the origin is there, roughly. Doesn't have to be perfect. I'm just going to make a duplicate of. I'm going to move this over here, give it a bit of a rotation of value so that it's not at zero. Oh, right. Let me get back to object. Sorry about that. When you're in gimbal, you cannot use the spaces between the circles. You have to use the circles. Kind of defeats the purpose of gimbal if not. All right. So I was an object. I was able to set this up so that now we have all these values that I'm not going to memorize if I ever have to go back to the initial position and rotation. The other thing I'm going to do is I'm going to make a duplicate of it twice, because we're gonna need them in the future, and I just want to have them be exactly the same from the get-go. So thinking about this object, the first thing that you might be tempted to do is, well, I want to zero out these values, right? So I could use a freeze, like you can go to modify freeze transformations. So you open that up. I have a button for that. So and I'm just gonna freeze all three of these. Okay, I'm gonna press it, and presto, everything's at zero. It's at zero. So yeah, so it's good, right? Okay, so let me ask you this: the object is clearly not at the origin, and we said that the value that's up here, or the values that it has to is always the difference between it and its parent, right? Or it's always relative to its parent. So if this is all zero, shouldn't it be at the parent? Like this object didn't have a parent, but when that happens, the world becomes the parent, right? So it's the same thing. If I had frozen this and it was connected to a parent, it would have given me the 0 values, but clearly whatever offset I had from the parent would still be stored this exactly the same way I've been doing here. Somewhere there's storage of where the like these values are, like where are these values. So so it's part right. So if I look at the to make this video as short as possible, I'll just jump right into the fact that this object, if we look at any mesh, a mesh, if you have the shapes it can show you the shapes. You'll notice that it's a transform node with the shape value, meaning the vertices, the triangles, and all that. All that information is stored in the shape, and then it's piggybacking off the transform node. So there's this concept of a transform node, which can move in position and rotation. There's only one other object type that can do that kind of thing, and that's a joint. We'll talk about that later. But right now, we're going to be looking at something called pivots. So if you look at the local space values and you grab another one that didn't get the freeze transform, you'll notice that the ones without the freeze transform that still have its values have a local space that is 0, and over here those values have been moved over into this local space. So that means that the reason why it's over here and not at 0, 0 is because it stored the information as like a sub secret, like a little place where it can do that. But what you're going to notice is that it only actually has the translation, even though ironically they labeled it the local rotate pivot. This is clearly from modelers. This is a way of moving a pivot internally on the object and being able to transform relative to it. But from the point of view of an animator, we've kind of lost our rotation. And if you think I'm messing with you, just switch to rotation, and you'll notice that it's aligned with the world. And if you look at the original one, like I was able to do this on the x-axis, I was able to roll it. No matter which space you switch to, you will not find anything that allows you to get back to having it spin. So when you did the freeze, it lost the information about rotation, so it could zero it out. And but you did hide the translation, which is valuable to us, right? Because now if we were to animate translation, it would be from 0. So this is not a good way to work, because meshes in Unreal don't allow you to be able to store a rotation value to 0 out. You lose your orientation. This is not good. All right. So if we go back to this object and we go, okay, how do we fix you to have the values we want? If we consider what we just read 2 minutes ago, I'm just going to create a locator, and then I'm going to get the locator to match my cube here. So I'm just matching it. All right, so this locator should have the exact same values as the cube, because they're two nodes that are child of the world. But now we're going to make an actual parenting where the cube now is child of the transform node, or the locator. And sure enough, everything's been zeroed out. Did we lose our rotation? No, it's still there. And the position, if we go to the object, relative to the object, it's still 0, it's still fine. So what happened here? Like there's nothing, like if I go to the cube's pivot for local space, it's still 0. It's not hiding any values, it's clean. Okay, so that's what this was all about. This is the hierarchy doing its thing, and we know that that this is correct, and that we were able to use that knowledge to be able to zero it out. Now, the disadvantage of this method is that you've created an extra node that has to be part of the hierarchy. So that means that if, let's say, you wanted to zero out a knee, you'd have to have this extra node before the before the thigh. It's kind of ridiculous. You'd have extra nodes everywhere to be able to zero out the values. So that's not what we want, especially when it's not going to work for IK in particular. It's not going to like this. So this is an issue. We can't have these extra nodes. However, we can use this in certain scenarios where you have like an IK controller. An IK controller, like the actual object that is the goal for the hand to reach, that thing can be zeroed out this way. So at least you can zero out the translation and rotation very easily and just hide this object, and it's not a big deal. It doesn't bother you. However, in a hierarchy, it's going to be a problem. So if we look at something like this, and I bring that up in space like so, and I rotate it like so. So this object is different. It does not have because it's not a mesh, it does not have the pivot. You'll notice there's nothing here that says pivot. And so so already we can't do a freeze, so to speak, of translation. And we could try, like, let's say I grab this guy and I try to freeze it, and I go freeze translation. There was a little decimal thing there, but that's just a rounding issue. But for the most part, like, the numbers are still the same. It's still 9.5 on the X, so that's a problem. And you can't really freeze that translation, right? So, but one thing you will notice is that your rotation from the get-go, from creating these joints, is already at 0. So how is that possible, right? Just think about it for a second. How would rotation be zeroed out? The answer is the same as the cube, except they have an internal thing where it stores the rotation value, where it's called the joint orient. It stores the initial rotation values there, so you can animate on top of 0 on rotation only. It doesn't do translation. So that's a bit of an issue with Maya up until a couple of years ago, where you can't really do both unless you do something like what I just did here, where you add extra nodes into the hierarchy. Just real quick, if you're using Blender, depending what parenting method you use, it gets complicated. I wouldn't start with Blender to learn how to do this stuff, because you have so many different parenting methods that it can really make it difficult to understand what's going on. Because you can even store the translation and rotation that is at the moment of parenting, so that your values are exactly the same. That when it's not something useful to you as an animator. It's only good if you're a modeler, really. So I wouldn't learn this stuff there. Maya is actually really good for this kind of stuff once you understand that meshes have translation, joints have rotation that can be stored internally inside the object. But one of the best softwares out there is actually 3 Studio Max. No, this Character Studio doesn't mean that's always going to be how you rig things. Here's an actual rig inside of 3 Studio Max, taking advantage of its robust actual setup. So believe it or not, this is something that's very unique to Max. There's other softwares that have done similar things, but as far as that goes, like what we're talking about, here's the transform of the object, like just this bicep here, and the position, for example. It has actual layers that you can play with. You have one layer that's for the initial, right? Your bind pose. Then you have another layer that's for IK, and then you have another layer that's for animation, which includes layers of animation. So it's what we call takes. So in other softwares, so the concept of being able to store multiple layers of animation separately on top of what the initial is and what potentially what the IK is, and being able to blend in and out the values of each one of these layers seamlessly on any type of position or rotation on an object is actually quite valuable. And we really don't give enough respect to 3 Studio Max. It had actually some really amazing things. Like you can see right here, you have like the weights, so you can control how much of each one of them was active, and that's all built into one object. So it's like you set that up for all objects to follow the same thing. You could have your layering system built into the object without having any extra nodes externally. It was quite optimal. But and that was one of its robust things. That's why I never say that any one software is better than any other, because it depends on what you're talking about. Each software has its pros and cons. Like Maya is very powerful for certain things. This is not one of those things. Until recently, now there's been a kind of a fix. So I will go over that thing that they added that we've been all saying for many years, that it was about time they added it to the software, which is if you look at any object inside of Maya, all right, not just meshes to be clear, a mesh is different from a joint because the root, let's call it like the core of the object, is a transform node. It's this little white thing with a red arrow. That is a transform node. And on top of that, you have the shape, which is the vertices and faces, right? In the case of a joint, it is not a transform node. It is a joint as the core. And it has its joint orient values, like we said before, where rotation can be stored, but the position can't. So those are the two basic different ones. So here's a quick way of showing you what that is. If I create a Maya locator and I make sure that I can actually see the shapes in my outliner, you'll see that that object is actually a locator at the core or a transform node at the core, and then it has a shape which draws these little lines as the sub child to the like a sub node to the transform node. But if I had this, so I can't see the shapes, that is the one object. It's just that internally there's even, it breaks up into more pieces, right? So just knowing that, you could consider the idea of creating a joint node, making it so it visually doesn't do anything, it doesn't draw like a joint, but then has the shape on top of it. So that's what this button is for. You can create a joint locator. Looks almost identical to the other one, but fundamentally under the hood, you have a joint with a shape attached to it, and it's just made to look like a locator, but it has the ability to have a joint orient. So if you're wondering why I did that, is because there's limitations in Maya for skinning, for example, or certain tools don't work. They only work for joints, and you have to have joints in order to be able to skin something. So if you wanted to use a locator as part of a skin, you can't unless you use what I just did, which is it's still a joint. So technically, all that stuff still works. Same thing goes for IK. IK itself, you cannot include something that's just a transform node at its core because it requires these things that are like the preferred angle in the joint orient. It requires these informations, these bits of information to be able to do its calculation for IK. And if you use something that has a transform node, it won't work. This is where I'm getting to with the sushi rig. The sushi rig in just about every software, you take a mesh, you take it apart into little pieces, and then you parent them together with the pivots aligned correctly, the names and so on, and you have your hierarchy, and you can set it up with IK and everything, and you can just animate that. You don't need to do any, you don't have to make joints or bones or anything. That your rig is literally those pieces that you cut apart. Unfortunately, in Maya, you wouldn't be able to add an IK to it because the mesh is technically a transform node at the core. And so a sushi rig wouldn't be possible with that method. But if you were to take joints and simply attach the visual component, the shape of that mesh onto it, then you're back in business, which is what we're going to be doing for the second part of the sushi rig, so that we can actually start creating a rig for it. All right, so that's a lot to unpack, but at the core here, we're just trying to do what we can to basically get values that are at zero safely, doesn't break IK, allows us to skin things. And in Maya, that's normally just the joint itself. That is what you want to be working with. And here's the fun thing. In recent years, I think in 2021, Autodesk introduced something that all of us techs were asking for, which is the offset parent matrix. This is kind of like this setup where you have an extra node, right? Except you don't need to add the extra node. It's inside the node. So this cube, you could just put the values of the parent here into the offset parent matrix, and it would be like an object inside an object at that point for both translation, rotation, scale, everything, the whole kit. It's like it's a whole object basically as far as transformations go, and that's like having a free object inside an object. And allows you to zero things out perfectly. So in the case of, let's say, this this joint, you have a translate of some value, which means how much it's traveled along the x-axis from its parent, which is the exact length of the parent. So if I were to grab this value and put it into the translate over here, and zero this out, it'll be exactly in the same place. Your value for translation is 0, and you have essentially stored that into a place that an animator won't touch, because if you look at the channels, it's zeroed out for translation and rotation now. And you can use combinations of that. And that's a wonderful tool to have. So now that it's here and all of us are rejoicing, if you get to work at a company where they were not able to freeze or lock the channels for you to set it to zero, and you just selected everything and try to go to zero, um, and then all of a sudden your character became really tiny because you've effectively made every bone the length of one, the length of zero. I mean, um, you've accidentally done that. Then know that you can fix it by simply anything that you want to zero out, grab the value, put it into the parent offset, the offset parent matrix, without them knowing, without the text knowing, and you're going to be just fine. Your shot will be easy to zero out. Now, normally riggers do lock it out, but there are scenarios where you can't lock it out. So, for example, an IK controller needs position. So, what do you do with that if it has a value and it hasn't been, like doesn't have a node like this added to it so that it goes to zero? If you receive a rig like that, you're not going to start remembering its position value to be able to go back to its original state. Like, this is not acceptable as a starting point for animation. All right, so you can use the parent offset matrix. Now, the other thing to note is that the parent offset matrix uh, is not included in a lot of what Maya has built, like like all the traditional constraints, and IK does not take that into consideration. So you can break things if you're not careful. In fact, the rig that I'm working on has that being taken into consideration, and I'm going to forget about joint orientation, joint orient. This is an archaic thing that we need to get away from. And the mesh thing with the pivot offset, that's also something we need to get away from. That's not meant for animation. We need to start using this. Even in the documentation from Autodesk, this is something that it says that your rigs can benefit from an optimization if you use this. This is exactly what we need it for. And so all the constraints that I'll be building will be taking this into consideration. I'm rewriting all of my stuff so that it works with that. Hopefully Autodesk will do the same thing with the ones that are inside of Maya. So we can get move on from this thing, and that'll be nice. The other thing that I want to mention real quick is that if you use this method, or if you use the offset parent matrix, you're also benefiting from the same thing. There's a defense to gimbal issues that I mentioned at the beginning of the video. So if you look at this thing, this object that hadn't been affected in any way, and I go to rotation and I go to gimbal, you're going to notice that already we're starting to see the this is gimbal here, right? It's not as good as if it was starting at 0, because we have values already like rotation of y of 31. Means we're starting already. If this was our starting point, this would be bad because we're already getting close to gimbal. Whereas if you look at this one, your gimbal ball is perfect. It's the furthest it can be from a gimbal lock as possible because all your values are at 0. So having these kind of nested systems or parents that are aligned the same way type of deal, this allows us to be able to have some sort of protection against gimbal. And this only works inside the DCC because you have to understand that every software is different for how they deal with this, and you can't really export that to an engine. So if you're talking about game engines, this all gets flattened. So the concept of a joint orient gets flattened, and the values are the final result relative to the parent, like the purest form of this that you can have, where there is no hidden anything. It's not stacked anymore. So, anyways, point is, having this is very handy. It's good for animation. It's good against gimbal. It's clean. It allows us to separate the concept of the initial from the animation. There's nothing but good into understanding how to use this. So okay, so it's a long video, but there's a lot going on here, and there's a lot of things that we should consider when building a rig. The final thing that I'm saying here is that zeroing out the values of node is beneficial for many reasons. So let's do what we can to, when we build our rig, to make sure that everything is always zeroed out as much as possible. And you should have a much easier time to animate that rig. All right, that's, I think, where we're going to end the video.